Hey, what's up? It's Jake from Nimbus DevOps, and today we're going to go over Kubernetes deployments. So deployments are really fun because you can essentially create things and have different versions of them without needing to delete and recreate the resources on your own. So let's go ahead and start taking a look at a deployment definition file. You might recognize this file format because it's actually exactly the same as the replica set format. The only difference is the kind. Here in line 2, the kind for the deployment is deployment. So why? Like what is the difference between these two? Well, you can think of a deployment as its sort of wrapper around a replica set, and the deployment's job is to roll out updates and be able to roll back updates that would impact the replica set to deploy the pods that you want without the need to go in and do a delete everything and then recreate it yourself. That is one of the limitations that we saw when we were playing with replica sets. So if you don't remember, or if you haven't seen that video, I will show you now. So the first thing I'm going to do for this session is I'm going to create an alias because I don't want to type kubectl 10,000 times. And we're going to do a get all, and I should just have my cluster IP service, which I do. So I'm in my replica set directory. We're actually going to create the front end replica set, which should have, let's do 3 replicas of 3 pods with Nginx containers in them. So we're going to do a kubectl apply -f, and then let's do our front end replica set, and then kubectl get all, and our pods are being created, and they are ready. And there you go. So let's close the deployment definition file for now. So this replica set definition file, if I wanted to scale this to 5, I would change this declaratively and then reapply. And if we get all, we now see that we have 5 pods. And if I wanted to scale it down to 2, we would again run and apply. Again, this is for the replica set, right? We get all, and I can see that it's already deleted the other 3 pods and we're down to 2. But what if I want to change the Nginx image version to say 1.18 instead of 1.19, which is the latest? So if I were to change this image, note the pod name specifically, BSB and ending in BSB and W8Z Zulu. Well, if I run the apply, Kubernetes is going to say I need 2 pods that match this label, and that's as far as it's going to go. And if you do a get all, you're going to see it already has 2 pods that match that label, so it actually doesn't delete them. But we didn't apply, and we made a change to the image, but it didn't actually change the pods, right, or the containers in the pods. Because if I do a kubectl describe pod for this guy, well, you can just do this too, pod slash. So if you do this, you can see that the Nginx image was pulled 107 seconds ago, and that the image doesn't have the version on it. So if you update the image in the container spec of your replica set, it doesn't actually update this. What you would actually have to do is delete your pods. So if I now said kubectl delete pod, let's just copy this. Well, yeah, let's do it this way. If I do the kubectl delete pod, this guy, and then this guy, it's going to delete both those pods and recreate pods because the replica set says that we need them, right? And now I have new pods. So if I do kubectl describe on this pod, we can see the image now has the updated image version. So that's kind of a pain, right? It's a pain in the butt. You don't want to have to do that. And if I want to say, oh, I don't want that version, it broke something, I want the latest version, I would have to go through and delete everything all over again. So deployment solves this problem by being able to roll out updates and have it manage the replica set for you by doing something pretty cool. And that's it. It creates a second replica set and then just load balances everything off of one replica set onto the new replica set, and we'll be able to watch that in real time. So let's go ahead and delete this replica set and I will show you. So we're going to do a delete replica set for front end. And now everything is gone. So let's go ahead and close this and let's check out our deployment file. So like I said, the deployment file is exactly the same. The only difference is the kind is different. It says deployment. And we're going to use the exact same commands, except we're going to use deployment instead of replica set. So I would say kubectl apply that. Oh, wait, let me get to the right directory. Here we go. Kubectl apply -f our deployment file. So now if I do kubectl get all, you'll notice one extra resource. I have a deployment here. This deployment created a replica set, and the replica set created the pods. So you're just adding one extra layer of abstraction, as like I said, as think of it like a wrapper around the replica set. And like I said, instead of creating them, we rolled out an update. So if I were to check the status or want to see the status of a rollout, you would run kubectl rollout status and then our deployment / web app deployment. And you can see that it was successfully rolled out. You can actually watch this in real time as well if you do it fast enough. So I'm going to do a kubectl delete deployment web app deployment. And we're going to run our apply command again. And I'm going to run the rollout status command really fast and you'll be able to see it. So you can see 0 of 3 updated, 1, 2, and then finally 3. So it was successfully rolled out. And you can actually see a history of this as well. And it's just same as the previous command, except instead of status, you can just type history. So kubectl rollout history and then pass your deployment, and you can see that it was just created. So we're on revision 1, and there's no changes being logged in here. There is, in other videos I've seen, like if I wanted to update this to 5 and then roll out a change using the apply command, a flag called record equals true, but it's deprecated. I'm not exactly sure what Kubernetes is planning to do with this, but if you run this, it will record it. It'll just tell you that it's been deprecated, but I don't know exactly what the replacement is yet. So yeah, so now if I look at the history, you can see that there's a revision, and it says it's because somebody ran this command. And then I can look at this file and look at the version of it and stuff. And we should also see that we now have 5 pods. So let's look at the problem that we said it was going to solve. So yes, we can scale up. Yes, we can scale down. I'm just going to take this record off because it doesn't do anything really. And now we should see 2 pods, and we do. We still have the same replica set. So now I want you to pay attention to the pod names and the deployment, or the not the deployment, the replica set, the specifically desired current and ready numbers. When I change this image to an older version, what you're going to see is it's going to create a second replica set, start load balancing traffic off of the replica set, the previous one, and then onto the new one. And actually, just to make this a little bit easier to see, I'm going to make 10 replicas so we can watch it in action. And we can actually do the rollout status right now and see it building our replicas. Cool, so now I should have 10 pods, and I do. Okay, so now let's change this to an older version of the image. And as we saw with the replica set, the pods do not get recreated but with the deployment, they do. So let's go ahead and apply this. We're going to check the status, and you can see it's actually rolling out new ones and replacing the old ones. And when the new one is up and ready in a ready status, it will delete the old one. We can also undo this. Like, let's say that this broke something. You could do this and then reapply, and that would work just fine. And if I do a get all, you can actually see the numbers here. Here's our previous replica set and then the new replica set, and it's just load balancing them off until it gets them all to the new one. Well, if I did not want to do that declaratively, I want to do it in the command line, you can actually run a kubectl rollout undo command and pass the name of the deployment, and that will just rewind. See, it's starting to shift them off of this replica set and back onto this replica set. And we're almost off of this one. And we are now completely off of that one. And you'll saw that it said ready 9, for example, right before this. But the current desired was 10. But I didn't have 10 up. So there's actually there's a configuration you can change. We're not going to do it now, but we'll do it later. Video where you can say, hey, I need 20. If you're going to do rollouts, like, I don't want any more than 10% of my desired state to be down when you're doing these rollouts. So you can kind of tell it like what percent of your desired state you would like to be up at all times. And what's nice about this compared to deleting and recreating things with a replica set is this gives you zero downtime for updates for rolling things out. So whether you're updating your code base and then doing CI/CD triggers to recreate images that then get deployed out to the CD part of CI/CD and creating rollouts for rolling updates on your Kubernetes cluster, this is just a great way to do it. So let's talk about that. So there's two different deployment strategy types here. You can recreate, the recreate strategy where you delete everything and then you recreate it and you will have downtime. Or the default deployment strategy in Kubernetes is the rolling update where you replace them one at a time like we saw here. One or two at a time, or whatever. It depends on how many pods you have. So there is a way to change the image in the command line. I don't know that you'll ever want to do this, but there's a set image command you can do, and then give it the deployment and our, web app deployment, and then tell it the name of the image. It is imperative. You can see the image equals like nginx. I think there is a nginx equals nginx latest. So I can tell it, hey, on this deployment, grab this pod, this in this image, change it to the latest. Or I can say change it to 1.18. And you could do it imperatively like this. But again, none of these changes are being tracked in your actual deployment files. So I would highly encourage you to do it this way instead. So yeah, that's pretty much that part. We can look at all of our stuff and see what it's doing. We can do the get status and just make sure that it's successfully been deployed. Here's our rollout status. It's almost done. And that's the bulk of what you need to know for deployments. As far as rolling things out and undoing them, getting the status, looking at the history, updating images, yeah, that's pretty much it. So hopefully that makes sense, the difference between the replica set with deleting and recreating it with the recreate deployment strategy versus the rolling update deployment strategy. There are some things you can edit in your definition file to define these specifically. And if I were to try to do that imperatively, I can probably show you right here. You can see here, this is what the full file would look like. And let's see if I can find it here. Yeah, strategy, rolling update. So my max surge 25%, max unavailable is 25%. Type is rolling update. So if I had changed the strategy from rolling update to recreate, it would delete everything and then recreate it. If I do the max unavailable, this is where you can define I only want 10% of my resources to be unavailable. You know, then if you have 10 pods, only one of them is going to be down. If I have 25 like I do right now, then it's possible that at any point in time during a rolling update, I could have 4 pods unavailable and have a max of 6. So that's just something that you need to decide with the uptime required and the resources required to serve the traffic during the time when you decide to do rollouts. Hopefully you're doing it in off-peak hours or even giving people some sort of maintenance notification. But that's pretty much it. We didn't go over all of these fields. There, of course, is just an easy way. You're one Google away, Google search away from going to the Kubernetes documentation and getting a full version of this. As we did before, you can also just build a sample file with an out command. So I could do, like, let's say I want to do a create. I want to create a deployment, right? And I'm going to say, you know, the replicas are going to be 3, and you could do the whole, you know, pass all of the things you want into, or and then just do an output flag into YAML into a sample file, and then you could have yourself a file as well. So it's the same thing that I did for generating a pod file. But that's pretty much it. So if you have any questions, let me know. And if not, then hopefully you get to go create some of your own deployments and have a good time doing it. The next thing is going to be up will be Kubernetes services. So go ahead and master pods and replica sets and deployments. And once you've got your head around deployments and you can answer all the things that anyone ever wanted to ask you about those 3 entities, then at that point I would move on to services. All right, good luck. I'll see you later.